Hello everyone, welcome back to our Azure DevOps learning series. Till the last few sessions, we have learned about how to integrate multiple security tool, code scanning tools, and get it implemented in your CI/CD pipeline. And we talked about how easy the Azure DevOps has make it to integrate by just adding the extension. And after that, Azure DevOps provide us a different task related to those extension, and it is easy to integrate all the different security tools and the code scanning tools, including the Sonar Cloud, Sonar Cube, Veracode, Snake. Today we are going to be talk about a next deep level part of the CI/CD, specifically within an Azure DevOps, to deploy your application using the Helm chart. It means we are talking about the Kubernetes containerization. Yes. In the today's session, we will talk about a detail about the Helm, followed by we will discuss about later on to the use of Azure DevOps with the Helm chart to build and deploy the Kubernetes based images. So what is Helm first of all? Helm is used to simplify the Kubernetes application deployment and management. It's not like we can only use the Helm. There are many other ways to create a separate YAML file for the Kubernetes deployment, but how the Helm can simplify the Kubernetes application, that is where the Helm is going to be helped with the reusable template. What can be done without Helm? It means that for deploying the application to the Kubernetes, usually you need multiple type of YAML file to be created. I have put some example that you need to be created separately for a deployment YAML file where all the deployment related, the port details that needs to be mentioned, or where the exactly the image is available, followed by the type of services that is. So there are multiple YAML files that you have to be create individually for each and every microservice, each and every API, or each and every image that you need to be deployed. But Helm help us to be package all those YAMLs together as a reusable single component or a unit, which is called as a chart. That is where the Helm part came into the picture to make it reusable template, easy to be used, standardized across your project and an organization. And whenever there is an upgrade, how easy Helm can be upgraded and used, and it can be accessible across the enterprise CI/CD or the DevOps wherever you are using it. Okay. Helm help us to package the Kubernetes manifest into the reusable template, and we will talk about the template in a minute, that how the template has been defined and where exactly you have to pass the values as needed, keeping the template as same without any change. Okay, let's go and first discuss about those templates which Helm provided, and there are many more that you can create it as per your need within an Helm to make it reusable and make sure that it can be used or it can be configured once, and then by passing the value you can use it. Okay, here in the new project under the same DevOps learning series, I've created a new project, a new branch as Kubernetes. There I've just put as an example of how the templates look like. I've given the name here as a my app chart. You can give any name to this particular folder when you are going to be created. However, under this, the structure should remain the same, where you should have one values.yaml file, should have one chart.yaml file, which is the manifest file for the Helm to be used, followed by the YAML values file. The values file is always having all the value that you want to be used. It is like If you remember, we talked about the template and parameters. So this contains all the parameters or all the value that you want to be passed to the template. Now talk about and coming to this particular area which called as a templates. I have put it as an example right now for this video as a two template. One is deployment.yaml. What this deployment.yaml is, this is being used to be defined what deployment do you want to do onto the Kubernetes cluster. Means that which particular image you want to be deployed and how many ports that you want to be create. And this is a basic template where it has been mentioned the version that we are going to be use. Kind means whether it is a deployment type or it is a service type or any other configuration that has been defined as part of the template, followed by a metadata name that you can define. But this is where we have used the values that has been passed as part of this Helm chart. If you can see here, I have put it the replicas means the how many ports I want for this image to be deployed, and the value is coming as values in this particular one, followed by a parameter with the name as replica count. Similarly, within a template, I mentioned that I want to be create a container. I've defined just a name, and from where the value can image can be picked up. Under the value, there is a subsection called as image, and then followed by a parameter or a value with the name as repository, and then a tag. Now let's see how these things, these that has we can see here the replica count, images and tags, how this has been passed from the values. Now you can see here within a values I've defined the replica count as a key and its value is 2, followed by under the image again there are two parameters, one with the name as repository. I've given the path of the repository, followed by the tag. I've given whatever be the latest, please pick it up. These are the variables or the values that has been used under the deployment.yaml, followed by a service.yaml. Again, what type of and how your Kubernetes image get deployed, whether it will be a load balancer type or it will be as a cluster type, means it is only been accessible within a Kubernetes cluster, not outside. So that type of service has been defined under the services, and here also you can see the value that get changed is from kind, from deployment to services. Means Kubernetes or Helm can be identified as a service type of template where what all value that has been passed it up, any name that you want to be give it up, that is what it has been given, followed by this. These are the one where you can see that this template is going to be pick up type of service, whether it's a load balancer or a cluster, and if load balancer, then what is the IP value that is going to become up. Now let's see on to this one, the values.yaml. You can see the type, it is automatically going to be passed under the service as a load balancer, and then the load balancer IP with whatever be the IP that has been agreed based upon your project. You can pass that particular one here. What you are going to be get it out from this chart or this Helm, that your chart or the templates remain same. You don't have to make a change into your templates. It always remain the same. Where the change is coming up under the value, that where the image is, what type of image, what type of service, what is the IP address, everything can be defined under the value section. That is how Helm make it pretty easy to do the Kubernetes cluster deployment by maintaining the reusable template and only to be pass all the details to the values.yaml. And there are many other templates that you can create or need is like the ingress.yaml, the secrets.yaml, or any helper that you have to be created. All those things can be created under the template, whatever that has been needed, but the value can be passed it up from the value.yaml. That is where we have described that how the Helm will make it easy and consistent across all the environment to be create the template once and just change the value wherever it is needed without to be make a multiple deployment YAML files that used for the Kubernetes cluster. Okay, the next part I would try to be explained in a way that how easy with a one single command that Helm can helps to be deployed all those templates. You can see here I've just put it as an example, Helm install, and it is going to be install all the templates that is under the chart with this name. However, if you can go without, you have to do apply of all those YAML file whatever is needed, and it is going to be sometimes very difficult to be figure it out that what and which environment you are getting it deployed to be make sure that each environment have appropriate correct deployment file or the services file or the ingress file. Okay, there are two more benefits that Helm can provide pretty easily, that if you want to be rolled back to the previous version using the Helm commands only, then Helm will provide a rollback support by just mentioning as Helm rollback. It will go to the previous version. However, if you want to go with the specific version, you want to see what all different version is being available for the particular image, that version control is also being managed using the Helm history followed by your app name that you have been defined initially as part of the chart. That is how the Helm templates can be created, and on the upcoming next video we will see how these templates that we just learned about can be used within our Azure DevOps CI/CD pipeline to build a code and also to deploy the code by pushing the image to the ACR, which is a Azure Container Registry, followed by the Kubernetes cluster. Thank you so much.